What we're asked to do now is to solve the linear systems, but we're specifically going to do so and illustrate through the elimination method. Ultimately, what the elimination method really is going to try to accomplish is it's going to try to eliminate one of the variables so that then we're only left with the other variable that then we can solve for that particular variable's value and then substitute that in to find the other variable's value that we had eliminated. So what I'm going to do right here is I'm going to take this system right here where we've got two different equations, and what I will do is I'm going to take this side of the first equation, which of course is equal to that other side, and then this side of the equation. So these two sides right here, I'm going to add them together, and we can do that, which then means that then these two sides of the equation, I'm going to add them together. And when I do add all of that together, so when I add negative 4x plus 12x, I get 8x. And then I add 1y with negative y, I get 0, right? And then negative 8 plus 16 gives me 8. I basically get this now, that 8x equals 8. Now, just a moment before we proceed any further, the reason why we're able to do this and why this works is when you do have an equation where like 7 equals 7, so this side equals this side, and then you have another equation like 23 is equal to 23, then it does make sense, right? That if I add this 7 with this 23, that whatever I get right there will have the same worth as the other side because this part is the same as that part and this part is the same as that part. So you will get a resulting inequality when you do such. So what's happening right there with numbers is exactly what's happening right here. But what resulted right here when we got a 0 is we eliminated the y's because we added a positive 1y with its opposite, the negative 1y, and hence we eliminated. So this is why this is called the elimination method. And then what that does then is it gives you then just the x variable alone, which allows you to actually solve for it. So when you divide by 8, then you end up getting that x is equal to 1. And then, at that point, you can just substitute the 1 back into one of the two original equations and then solve for the y. So if I take that and I substitute x, say, into that equation, the negative 4x plus y equals negative 8 equation, then by putting in the 1 right there, we end up getting then negative 4 plus y equals negative 8. And you can add 4 to both sides, and that's going to give you y equals negative 4. So those should be the correct values for x and y, which of course you can check by plugging into both equations, which you know how to do, so I'm not going to take the time to do so. So it does turn out that the solution to the system will be the point or the ordered pair 1, negative 4 then. So really, elimination is going to work well when you can have, opposites to be able to eliminate. So with this next example now, if I were to add this left-hand side of the equals with this left-hand side of the equals, what you'd really get is you'd get 8x plus 8y equals negative 8 when I add the right sides together, which doesn't eliminate anything because you didn't have opposites that eliminate each other. So if you don't have opposites that eliminate each other, you're going to need to create opposites. So it doesn't matter if you eliminate the x's or if you eliminate the y's, just choose one. And so what I'm going to choose to do in this particular example is I'm going to try to eliminate the y's. And the reason why that is because I can easily multiply the negative 4 to become like a negative 12 when I multiply it by 3. So what we are allowed to do is you can take one of the equations and you can multiply or divide both sides by whatever, and you still have the same equation. What I'm going to choose to multiply by is I'm going to choose to multiply by a positive 3, because then the first equation then becomes the following. And then the second equation, I'm not really going to change it at all. I could, because of commutativity of addition, I can rewrite it as 3x plus 12y instead equals negative 6, and that kind of lines things up nicely then. And then at this point, now I have a rewritten system, but now I do have the opposites. So then when I do add the left-hand sides together, I end up getting 18x plus 0. So therefore we've eliminated the y's in this problem. And then be careful here, when I add these together, negative 6 plus negative 6 is negative 12. So I really have 18x equals negative 12. And then it's just pretty slick. From here you can just divide by 18, and then you're able to reduce your fraction to become negative 2/3, and that gives you your x value. So with that, then you can substitute that back into one of the original equations and then get your y value. So I'm going to go ahead and how about substitute it in for the x in the second equation. So we can take and then do 12 times y plus 3 times your x, where we're substituting in negative 2/3 right there. So it really becomes 3 times negative 2 is negative 6, and negative 6 divided by 3 is negative 2. So it's really 12y minus 2 equals negative 6. So you can add 2 then to become 12y equals negative 4, and then divide by 12 so that you get y equals negative 4/12 or negative 1/3. So now you've got your x and y values. If you took the time to check, they both work. So it turns out that x being negative 2/3 and y being negative 1/3, that right there would be the solution to the system then. Alright, so with this one, I'm going to, for right now to start this off, I'm going to do this wrong with what might be a common misconception about how we might go about this. Because if I were to just add stuff together right now, it seems like, okay, negative 17q plus 4q is negative 13q, and then negative 9r plus 9r, oh, that's 0, and then negative 15 plus negative 15, oh, that's going to be negative 30, right? And so then it looks like we've eliminated the r's. But really, that's incorrect and wrong, because if we were to actually do this correctly now, so if I were to do this the right way in adding both sides, it turns out that if I were to add the left side and the right sides together, I would actually get negative 13q plus 9r, and then if I were to add the right sides together, I'd get negative 9r plus, or minus 30. So actually, we didn't eliminate the q's, nor did we eliminate the r's, right? So typically, I guess kind of what's standard in terms of doing an elimination problem is to have it so that you have your variables all on one side. So really a standard form of a linear equation. So you can see what I did there is I added 9r to both sides, and then take the other equation, and actually it's already in standard form, so I'll just copy it basically. And then you can see that now I actually don't have opposites right here. So even if I took this linear system right here and I were to add both sides of the equations together, you're actually not going to eliminate anything, because you'll get negative 13q, but then plus 18r. So you haven't eliminated any variables. So to eliminate variables, you need to have opposites and create opposites. So it's actually pretty easy to do so, because you just need, I guess, one of the 9r's to become a negative r. So either pick the red equation or the blue equation to create your opposites, and so I'll just pick the blue one just because, and I'll just multiply both sides by negative 1 in that equation then, which will then give me negative 4q minus 9r equals positive 15, and then I'll copy the red equation. Now we have opposites with the r terms, so if I add both sides together, now negative 17 plus negative 4 is negative 21q. That plus that is going to be 0, and then negative 15 plus 15 is 0. So now we've properly eliminated, in this case, the r's, giving us negative 21q equals 0. So if you just divide both sides by negative 21, then q is going to be equal to 0, and that gives you the q value that's going to satisfy the system. And then you can go ahead and plug in that that value into one of the equations. So I don't know, let's plug it in right there. So negative 17 times 0 equals negative r minus 15, and then we can solve for the r. So 0 is going to be negative r minus 15. You can add 15 to both sides, and then divide by negative 9. When you reduce that, you get negative 5/3 is equal to your r value. So I guess if we were to do this in alphabetical order, q comes before r, so 0, negative 5/3 would be your solution to that particular system there. And then one last kind of standard type of example that we can do by elimination would come through this example that we see right here. So notice that this first equation is in standard form where m and n are both on the left side and the numbers on the right side, and the same thing is true for the other equation. Now you'll notice that 2 and 3 are not the same numbers and they're not opposites, and we also don't have opposites right there. So we're going to have to try to create opposites somehow. You'll notice that the 2, the smaller number than the 3, doesn't go into 3 nicely, and then this smaller number 6 doesn't go into 7 nicely. So you're going to have to actually multiply both equations. So multiply this equation by the same number on both sides, and then you're going to have to multiply this equation here by the same number on both sides to somehow create opposites. So it does not matter if you create opposites for the m's or if you create opposites for the n's. It's totally up to you. So, like, for example, if I were to choose to eliminate the m's, then great. Then I'd have to figure out what 2 and 3 both multiply into, and one such number would be a 6. So if I want to multiply 2 by something to create it to be a 6, I'd have to multiply by a 3 to make that become a 6. And then I'll have to multiply the other side, of course, by a 3 as well to keep that equation balanced. So then if I want to multiply this 3, I'd have to multiply it with a 2, but then I'd have both this and this be positive 6s, and I want opposites, so I guess I'll choose that to be a negative 2. So since I get so that I will get then a negative 6m. So I'll have to multiply that side of the equation by a negative 2 to keep that equation balanced. So you're going to then get 6m plus 18n equals negative 12 for the first equation, and then negative 6m plus 14n equals negative 12 for the second equation when you do all that distribution. Now you've got your opposites, so that when you then add, you get 0 plus 32n equals, and then right there, yeah, they don't cancel out, so I guess you get negative 24, right? So then now that 32n equals negative 24, you can divide by 32. So n would be negative 24 32nds. That does reduce down to a negative 3/4 for your n value. Then, of course, you can substitute that n value in to find your m value. So if we substitute it in, let's say, into that first equation, then we would have that 2m plus 6 times negative 3/4 is equal to negative 4, and then we can solve that for the m value. So if you multiply right there, that's negative 18/4, which is the same thing as negative 9/2, which is actually negative 4.5. So 2m minus 4.5 is negative 4. So then you can add 4.5 to both sides to get 0.5 on the other side, and then if you divide by 2, you get 0.25 or 1/4 for your m value. So ultimately, your final answer would be 1/4 is your m and negative 3/4 is your n. And that gives you the solution for that particular linear system then.